Hey guys, welcome to the Raptors, a digital platform of the RAPT Excellent Tutorials. Tomorrow there is CBSE board exam for chemistry of class 12, and I have handpicked few very important questions that can turn up tomorrow. So these are few very important questions from first chapter, which is solutions. We'll take these questions one by one. The first question is, which parameter is better, molarity or molality? The answer is molality, because molality is moles per kg of the solvent. Here the molality don't depends upon the volume of the solution, whereas molarity is number of moles per liter of the solution. So this is molarity. Molarity depends upon the volume of the solution, whereas molality depends upon the mass of the solvent and the solute. So volume can change with temperature, whereas mass don't change. So molarity can change with temperature, and so if molarity can change with temperature, it's not a very good parameter. So molality is better parameter. Now you go to answer number 2. It says, what happens to the solubility when Henry's constant is increased? So you see, the solubility partial pressure is directly proportional to the mole fraction of that solute. So partial pressure will be like this. So chi A represents the amount of mole fraction of the component A. Now you see, if you increase Henry's constant, solubility will fall. So increasing, why it will fall? Because the product is constant. If Henry's constant is increasing, solubility will fall. If solubility increases, Henry's constant will fall. So increasing Henry's constant will decrease the solubility. Now we come to the third question. What is the phenomenon of bend? What is the composition of the oxygen cylinder of scuba divers? Now, what is bend? The scuba divers, they are going, when they are going deep down the ocean or deep below the river, the pressure of the water makes more gases getting dissolved in their blood. So what happens? Oxygen gets utilized, but the nitrogen, which is in larger amount, it gets clumped together. It stays in the blood because of the high pressure. Pressure increases solubility. So they get clumped together, and then when they get clumped in some area, they obstruct signal transmission, and that causes bending. So that phenomenon is known as phenomenon of bend. What is composition of the oxygen cylinder? Now naturally you want less amount of nitrogen, so the composition of the oxygen cylinder looks like this. Helium is 11.7%, nitrogen 56.2%, and oxygen 32.1%. So this is the typical composition of scuba divers, like oxygen cylinder of scuba divers. Now we are done with question number 1, 2, 3. We move to the next question. Now it says, why fishes are more comfortable in cold water than in hot water? So what happens? Due to increase in temperature, solubility of the gases decreases, because when you have gases dissolved in liquid, when you heat it, when you are going to heat it, these air bubbles will gain kinetic energy, and they will start moving out of the liquid. Now at higher temperature, less and less amount of oxygen will remain dissolved, but at lower temperature, greater amount of oxygen will remain dissolved in the blood. Now what happens at lower temperature, fishes will find more oxygen dissolved in the water, so they will be comfortable naturally, while at higher temperature there will be less and less amount of oxygen molecules dissolved, so fishes will be uncomfortable, they will suffocate, they won't be able to breathe properly, and everything will be obstructed, their motion, their daily routine will get obstructed if the temperature is warmer. So that's why fishes are more comfortable in colder water as compared to hotter water. Now we come to the next question, which is what are ideal and non-ideal solutions, and give their examples. So we come here, answer 5. Ideal solutions obey Raoult's law. Also, enthalpy of mixing is 0, and enthalpy of uh, volume, like volume of mixing, is also 0. Examples are n-hexane plus n-heptane, and we have more examples. Mm, bromoethane and chloroethane. And then benzene and toluene. These are the 3 examples of ideal solutions. For non-ideal solution, what are non-ideal? There are 2 types of non-ideal solutions. One shows, so in non-ideal solution, both will have, both won't obey Raoult's law. So both of them won't obey. Non-ideal solution do not obeys Raoult's law. That means, it also means delta heat of mixing is not equal to 0. Volume of mixing is also not equal to 0. Now there are 2 types of non-ideal solution, one showing positive deviation, other showing negative deviation. So in positive deviation, examples are ethanol and acetone, and in negative division, example is chloroform and acetone. All right, so the last question which is important from this chapter is what is reverse osmosis? Reverse osmosis is a phenomenon when liquid passes from its lower concentration to a higher concentration. So you see, suppose there is contaminated water. This is less contaminated, cabinet A and cabinet B. Cabinet B has contaminated water, and this is semi-permeable membrane. Now, when pressure is applied, so there is natural flow of water from A to B. So this pressure is known as osmotic pressure, and it is given by pi equal to CRT, where C is concentration, R is real gas constant, T is temperature. This is osmotic pressure. But when pressure of this amount or more than that, not this amount, more than that is applied on this side, the liquid starts flowing from lower concentration to the higher concentration. This phenomenon is known as reverse osmosis. Welcome to the Raptors, a digital platform of the RAPT Excellent Tutorials. So I have selected very few critical questions which may turn up tomorrow in your exam. These are, tricky questions which sometimes gets asked in your exam. So if you go through these questions, you can increase your marks by by 5 or 10 marks. So these will probably give you 5 to 10 more marks extra, guys. So let's just go through these questions very quickly. The first question says why mercury cells maintain a constant potential throughout its life. The answer to this question is since there are no ions involved in the mercury cell's final reaction equation. Final reaction equation. No ions are involved, and hence there is no chance of concentration of ion getting reduced over time. It can maintain a constant potential throughout its life, a constant potential of 1.35 volt, so around 1.35 volt. Unlike in Leclanche cell, where the final reaction involves ions, so its concentration falls over ions, and we see its life, over its lifetime, its potential falls with time. So that's the answer of the first question. Second question, what compound undergoes first order disintegration? Like a compound undergoes a first order disintegration, how much of its concentration is left after n half-life? So for first order disintegration, half-life formula is 0.693 by k, where k is rate constant. Now the concentration after n half-lives is given by r naught by 2 to the power n, where r naught is initial concentration, r is final concentration, and n is number of half-lives. So yes, so that's how one gets concentration after n half-lives. Next question, how to find the molecularity of a complex reaction? So a complex reaction is defined as a reaction which takes place in several steps. So to find molecularity, one will have to look at the rate determining step, or the step which is slowest in the process, or the slowest in the chain. So the reaction which is slowest gives you the rate determining step, and the molecularity of that reaction is the molecularity of the overall reaction. So now we come to the next question. From the graph, explain the kind of reaction taking place. So you see, guys, here the product is at higher energy and reactant is at lower energy. So you see, reactants are more stable than product. That only means that reaction is taking place in the backward direction. So the reaction is backward. You see, the product and the activated complex are separated by energy gap EA. So the energy gap is EA. Activation, this is activation energy. And this reaction is backward. If the graph is other way around, suppose the graph is like this. So this is reactant and this is product. So this reaction is forward. Now the next question, why can't copper displace hydrogen from its acidic medium? The answer is hydrogen has got reduction potential of 0 volt, whereas copper has got positive 0.344 volt. So copper gets reduced in place of hydrogen, and hydrogen is unable to escape the solution. So so there is competition between copper and hydrogen, where copper wins, it gets reduced and don't releases or don't displaces hydrogen from acidic medium. So the answer is reduction potential. Next question, what are mesh metals? See, mixed metals are alloys of lanthanides. So lanthanide 95% and iron 5% along with traces of some sulfur, iron and other metals gives you mixed metal. Why it is important? Because it is mixed with magnesium to give mortar shells, bullets, etc. So when it is mixed with magnesium, it becomes very hard so that it can be used as bullet shells, mortar shells, light flinter, etc. Now we come to water chelates. Chelates are ligands which can form two or more than two bonds with the central metal. So for example, ethane 1 to diamine, you see nitrogen here has got a lone pair of electron, it can donate it to the to any metal. So it is chelate, it can form two bonds. What is the best method to prepare haloalkane from alcohol? So thionyl chloride is the best method, is the best choice for reagent, because when it reacts with alcohol, it will give you a haloalkane plus sulfur dioxide and HCl. Sulfur dioxide and hydrogen chlorides are gaseous in nature; they will escape the solution, and you will be left with a pure haloalkane. So next question, why dry acetone is used as a reaction medium in Finkelstein reaction? Finkelstein is halogen exchange reaction, and you see it involves sodium, and sodium reacts very vigorously with water. So in other reactions as well, like Woods reaction where sodium is involved, and Grignard reagent type reaction, involving Grignard reagent, one is advised to use dry acetone, because it would react vigorously, very vigorously, and then reaction would get destabilized. So that is why, to avoid sodium getting reacting vigorously, dry acetone is used. Next reaction, why haloarenes are less soluble in water. The principle of solubility is um, the principle of solubility is it is based on energy. So the principle of solubility is when energy required to break older bonds is less and the energy released when new bonds are formed is higher as compared to the previous, the molecule will be, the compound will be soluble. In this case, the energy required to break older bonds are much more than when haloarenes are dissolved in water. When new bonds are formed, energy release are less as compared to energy required to break older bonds. So energy wise, the solubility of haloarenes in water is not feasible. That is why it is less soluble in water. Your exam. So let us understand crystal field theory first, and then we'll see what kind of questions can be formed on CFT and which questions may appear tomorrow. So yeah, let's proceed with crystal field theory. So you see, in crystal field theory, the idea behind crystal field theory is that d orbital of a central metal splits. It splits when a ligand approaches it. So when ligands approach this d orbital, so we are discussing octahedral complex, that this d orbital will go to the excited state and will split into two levels. The level that is going up is Eg, and then the level which is coming down is T2G. So the two orbitals which is going up, up is our dx square y square and dz square, and then orbitals which is coming down is dx square dy z dzx. So this energy level is barycenter, and you see 3/5 of the total energy of splitting energy goes to Eg, and 2/5 of the total octahedral splitting energy comes to the T2G. So T2G level is 2.5 of the total splitting energy. It is below 2.5 of the total octahedral splitting energy. Now you see how to keep this in mind. You have 3 orbitals, then it will be 2 by 5. Here you have 2 orbitals, so it will be 3 by 5. So just reverse. So that's the best way to keep this in mind. Now the question that can be asked from this is, why only dx square y square and dz square are at higher energy level, and y dxy dyz and dz are at lower energy level. So the answer lies in the shape of the d orbitals. You see, these are dxy, dyz, and dzx orbitals. These orbitals lie in between the axes. Their lobes are in between the axes, whereas dx square y square and dz square are on the axis. So you see, this is x and this is y. Now, in octahedral complexes, ligands approach the central metal through the axis. Now, when they are coming through the axis, they meet, they encounter these orbitals, dx square y square and dz square. Because of this, these orbitals get repelled and are at higher energy. While in octahedral complex, ligands are coming through, or they are donating electrons through the axis, these orbitals which are in between the axis, they get least repelled. So repulsion is smaller on these three orbitals as compared to these two. So these three orbitals are at lower energy. So that's how the splitting takes place. Now if you look at tetrahedral splitting, in tetrahedral splitting the ligands approach through in between the axis. So tetrahedral shape looks like this. You see, so when ligands are approaching or donating electrons through, like from in between the axis, they encounter these three orbitals, on their way, and these two orbitals are not encountered. So in tetrahedral complexes, these three orbitals get maximum repulsion, so they go to the higher energy level, and the other two, dx square y square and dz square, which are on the axis, they get less repulsion and they are at lower energy level. So this splitting, that's how the splitting takes place. Now the again same logic, you can use this logic to keep this in mind, that 2 5, there are three orbitals here, so 2 5 of the total tetrahedral splitting will go to the three orbitals, and then 2 3 by 5 to the two orbitals. Now if you compare the splitting energy, the octahedral splitting energy is almost double of the tetrahedral, so it is 4 by 9 of delta T. Now there is one more concept of pairing energy. What is pairing energy? Suppose there are 4 electrons in d orbitals. How would they pair up? How would one fill orbitals through those four electrons? So suppose we have octahedral splitting. So in this complex, 3 electrons, it will follow the normal Aufbau rule, Hund's rule, Aufbau principle, and Hund's rule. So you see, 3 electrons, 1, 2, 3 will get filled up as usual. So there is diagram here. 1, 2, 3 electrons will get filled. Now the problem is with fourth electron. What will happen to the fourth electron? Will it pair up or will jump it to the higher orbital? Now the answer lies in this. If pairing energy is greater than the splitting energy, that means if energy required to pair up with one of the electron is more than to go to the higher energy, then it will go to the higher energy. So electron will go to the higher orbital. If the pairing energy is less and it requires more energy to go to the higher orbital, so what electron will do? It will pair up. So it will use pairing energy concept. So pairing energy, it's the energy required by electron to overcome repulsion while pairing up. Now, one more question that can be asked from crystal field theory is, why coordination compound form colored compounds? Why they are colored? So the answer lies in dd transition. So that there is splitting in the d orbital, electron jumps to the higher orbital and then comes back. In that process, it releases energy which lies in the visible range. So that is why the coordination compounds are colored. Guys, we continue with another set of questions from organic mostly. So that question number 11 says, Why free radical halogenation is not preferred method to prepare haloalkanes? Because free radical halogenation gives you, a mixture of different haloalkanes. Because in free radical halogenation, it is a zero order reaction. First of all, it takes place in the presence of sunlight, and free radicals are formed, and then multiple halogen substitution takes place. For example, so if you have methane, and here what happens, chlorine gets dissociated in the presence of like ultraviolet radiation or sunlight, and this free radical will form chloromethane. This don't stops here, the further substitution takes place, so you have chlorine, so it will give you dichloromethane, and then trichloromethane and tetrachloromethane. Similarly, if you have any other any other alkane, you'll get multiply substituted haloalkanes. So, and it is very difficult to separate them out. So that is why it is not preferred method to prepare haloalkanes. Now we come to the next question. It is very extremely important question. Which one would undergo SN2 faster? SN2 order of reactivity is 1 degree, greater than 2 degree, greater than 3 degree. And for SN1, it is by carbocation formation. So it is 3 degree, 2 degree, and 1 degree. Now you see, both are, this is chloroethane, chloropropane, and this is iodopropane. Both are 1 degree haloalkanes. Now this is very interesting. Now, if since both are 1 degree haloalkanes, which one would be faster? So the answer is this will be faster. Why? Because iodine is there, and iodine is a very good leaving group. Why it is very good leaving group? Because iodine is larger in size, and the bond length with and because of its large size, the bond length is also large, and the bonds are generally weaker. So iodine is very it is always eager to leave bond and go away. So it is very good leaving group, and that is why it will undergo SN2 reaction faster. It is very interesting question and very tricky. Now I come to the next question. Why odd numbered alkanes are not advised to be made using Woods reaction? In Woods reaction, if you see the reaction, so one has CS3X plus Na plus CS3X, and this is in dry ether. You get CS3 plus 2NaX. Now you see, to start with, we had one carbon haloalkane, and the product we are getting is twice double. If you want to make odd numbered haloalkane, we'll have to take two different haloalkanes. Now when we take two different haloalkanes, so you see, odd numbered haloalkane will be formed, like we'll get propane in this case, but these two ethanes molecule will also react among themselves, and it will give butane, and these two also react among themselves, and you'll get ethane. So when you are going to make odd numbered alkane from using Woods reaction, you get mixture of alkanes, and they are very close to each other, and are difficult to separate from one another. That is why it is not advised to make odd numbered alkanes. Woods reaction is best for even numbered alkanes. Now we move to next question, guys, and this is why phenols are more acidic than alcohol. Alcohols, when dissociates, it will form alkoxide ion, and see, this alkoxide ion is destabilized by inductive effect, whereas phenols when it dissociates, it forms phenoxide ion. This phenoxide ion gets resonance stabilized. Destabilized by inductive effect. So to show resonance, let us see the resonance here. This electron will come here, it will come there, and it will get to form. Now this electron will form double bond and will go negative, and then so you see the electrons that is there on this phenoxide ion, it gets resonance stabilized and it revolves in the ring. So because of this resonance, phenoxide ion is stable, and since it is stable, it can produce more and more hydrogen plus ions. So since it can produce more H plus ions, it is more acidic as compared to alkoxide ion or like aliphatic alcohol, because this alkoxide ion gets destabilized by the inductive effect. So that is the reason. Now we move to next question. Why haloarenes do not undergo nucleophilic substitution reaction? You see, haloarenes, they have their electrons, they get their electrons, revolving in the ring by resonance effect, and you see because of this resonance, a nucleophile which is willing to attack gets repelled. So because of repulsion, and also you see because of this carbon which is sp2 hybridized. Now you see because of the resonance effect, and also because it is attached to the ring, this is sp2 hybridized, the bond length is shorter, and the bond is stronger between this carbon and halogen, so it is difficult to break. So mostly because of this resonance repulsion and then sp2 hybridization nature, and also because of steric hindrance, because benzene is quite a big structure. So these four factors makes nucleophilic substitution reaction very difficult. Now we come to very important question. Nitration of aniline gives meta as one of the major products. So how to explain that? Now you see, nitration generally takes place in acidic medium. Concentrated sulfuric acid plus concentrated nitric acid. Now in acidic medium, the aniline, the amine group here is basic. So what happens? It gets converted to anilinium ion. So it accepts one H plus and it gets converted to NH3 plus. Now since it is anilinium ion, it no longer gives its electron to the ring, and it is no longer a ortho para directing group. Instead, it takes electron back and it becomes meta directing, because if it will take electron back from the ring, plus sign, plus charges would appear on ortho and para position. When plus charges appear on ortho and para position, meta position is relatively is having more electron as compared to ortho and para. That is why when nitration is done for aniline, meta is one of the major products. So let me write down the reaction. The reaction looks like this. concentrated sulfuric acid plus concentrated nitric acid, you get major product. This is 51%, this is 47%, and then ortho is also formed. This is just 2%. So because of the formation of anilinium ion, which deactivates the ring, meta is also one of the major product. That was very interesting. Now, the next question, what is order of basicity of amines? Amines have got different order of basicities. So you see, so there are two facets or factors which determine the basicity of amines in the order of basicity of amines. So you see in gaseous medium, so there is gaseous medium, so amines, 3-degree amines in gaseous medium is more basic than 2-degree amine than 1-degree amine. That is in gaseous medium 3-degree, then 2-degree, then 1-degree. But in liquid medium we have ethylamine and methylamine. So for ethylamines we have so you see 2-degree, 3-degree, 1-degree for ethylamine, and methylamines we have, well, here R is ethyl. For methylamine it will be 2-degree, 1-degree, 3-degree, and then ammonia. This is one of the very important questions. Now, how to distinguish between 1, 2, 3-degree amines? So this is by using Hinsberg reagent. So Hinsberg test. So what is Hinsberg reagent? It is benzene sulfonyl chloride. So benzene sulfonyl chloride, it is known as Hinsberg reagent. Now, when Hinsberg reagent reacts with 1-degree amine, the product that it forms is this. Now you see, this hydrogen is acidic in nature. This hydrogen, because of this hydrogen, this product gets dissolved in alkali. Whereas if you react 2-degree amines, it will form and you see, no, there is no acidic hydrogen present here, so do not gets dissolved in alkali. Now, 3-degree amines, for 3-degree amines, we will see that 3-degree amines don't have any hydrogen present, so no reaction. So how to distinguish? First of all, we take first one solution. If it reacts with Hinsberg reagent and then reactant dissolves in alkali, then it is 1-degree amine because of presence of acidic hydrogen. Now, for 2-degree amines, it will react with Hinsberg reagent, but it won't get dissolved in alkali because there is no acidic hydrogen present in it. Now, for 3-degree amines, there is no hydrogen present, so it won't react with Hinsberg reagent. So there is no reaction. So that is how we distinguish between 1-degree, 2-degree, and 3-degree amines. Next question is, why Williamson synthesis while preparing 3-degree ether uses 1-degree haloalkane instead of and not 3-degree haloalkane? So answer to this is, the Williamson synthesis reaction is SN2 attack. Now, the order of reactivity we already saw that SN2 attack uses 1-degree, 2-degree, and 3-degree. That is why 1-degree haloalkane is used. So these were very important questions and tricky questions which may appear in exam tomorrow. So welcome guys, we go back to come to the Raptors again guys. So we go to another important set of questions which may come up later today in your exam. So the next question is, why sucrose is called invert sugar? Now you see, to begin with, sucrose is dextrorotatory and then the approximate angle is 66.5 degrees. That means it is rotating the plane polarized light towards its right. Okay, so if it is rotating light towards its right, it is dextrorotatory. But when you hydrolyze it in acidic medium, what you get equimolar composition, that equal amount of glucose and fructose. While glucose is dextrorotatory, fructose is levorotatory of minus 92.4 degrees. The overall rotation comes out to be minus 39.9 degrees. So from plus rotation to minus rotation, so on hydrolysis, sucrose goes from plus rotation to minus rotation, or from dextrorotatory to levorotatory. Now, because of this, because it changes its optical rotation, it is also known as invert sugar. Now, next question. Which reaction confirms the presence of primary alcohol group on glucose? So, glucose contains a primary alcohol group. Which reaction confirms it? So, it is the reaction with concentrated nitric acid. So, when glucose gets oxidized in concentrated nitric acid, we get saccharic acid. Now, this reaction is typical of primary alcohol. So, that explains the presence of primary alcohol in glucose. So these reactions were done to determine the structure of glucose, whether it is open chain or a ringed structure. Now the next question, draw the structure of beta D glucopyranose. So see, it is beta D glucose. So no, wait. So this is H and this is OH and this is yeah, it was fine. So how to look alpha and beta? If you draw a line from O, if OH group is on the left side, it is beta, and if OH group is on the right side, it is alpha. So this is alpha glucopyranose and this is beta glucopyranose. Now next question. What are proteins? Why insulin is also a protein? See, the definition of protein is it is a molecule made up of alpha amino acids whose molecular mass, total molecular mass, should be greater than 10,000 units. But insulin, which has well defined conformation, contains only 51 amino acids, is also a protein. So this 10,000 unit molecular mass is not an hard and fast rule. If a smaller number of containing amino acid compound is having very well defined conformation, that can also be classified as protein, just like amino acid, just like insulin, which is an hormone, and it contains 51 amino acids. Next question, what is denaturation of protein? So the structure and property of protein can be changed by the change of pH and temperature. Just like boiling of egg, it changes its nature, that is change in temperature, and curdling of egg, if it curdling of milk, because if you change pH, you add something, you add small amount of curd in it, so you change its pH, the nature of milk changes to curd, so it gets, so curd is made. So this change in nature, because of the presence of because of the change in pH and temperature, the process is known as denaturation. Now the next question, why vitamin B and C needed to be taken regularly? Because these two vitamins are water soluble, and on daily basis it gets excreted through natural processes. That is why you need to take it regularly, whereas other vitamins like K, E, D, A, like these are fat soluble, and they should be only taken once in 6 months, or on the advice of doctor. Now question, what is next question, what are essential and non-essential amino acids? The amino acids which are required in the same form and our body is unable to make it from the food we eat are known as essential. Non-essential amino acids are the amino acids which our body can make it. So we need to have essential amino acids in the same form, our body can't make it. So those amino acids are known as essential. There are few amino acids which are essential. I'll mention their name. So essential amino acids are starred marked valine, leucine, and one more, lysine, whereas these are essential. If we talk about non-essential, you have so many. So it is glycine, it is glycine, alanine, and maybe glutamine. So it is useful to keep at least 3 examples each of essential and non-essential in mind. Now, what are the bases present in DNA and RNA? In DNA, you have adenine, guanine, cytosine, and thymine, whereas in RNA, you have adenine, guanine, cytosine, and uracil. Now, to find complementary string of DNA, G always gets connected to C and A is always connected to T. So to find complementary strain of this DNA strain, C will get connected to G, G with C, G with C, T with A with T, A, T, G, C, G. So what you do, you use this rule, G gets connected to C, C gets connected to G, and A gets connected to T, T gets connected to A. So that's how you find complementary strain of DNA. So guys, these were extremely important few questions which you can't miss. If you go through these questions, probably your marks will get increased by 5 to 10 more marks. And remember guys, that chemistry tests your retention power. So retain these things while you go through these. Also retain these questions in your mind, so that it may help you achieve 5 to 10 more marks in exam later today. So I wish you all the best for your upcoming exam that is scheduled in couple of hours, guys. you have worked hard, I guess, and then all you need to do is stay calm, composed, and confident in exam. Give your best, write all the questions, and my best wishes are with you.